And welcome to video number 2, ladies and gentlemen, on representations of functions. So we've learned 2 now. We learned one on our last lesson, 6.1. I haven't reviewed that one yet. We're going to. And now we've learned a second one that is using the function rule. And that is writing an equation of the function. And so right now, all we're going to do is we're going to start off with evaluating that function, which is nothing more than what I like to call plug and chug. So it says, what is the value of y equals negative 2x plus 7 when x equals 2? So when our input is 2, what is the value of y? What is our output? So plug and chug means, hey, I'm going to write y equals negative 2 times 2 plus 7. And I'm just going to do the math. Order of operations style. And negative 2 times 2 is negative 4 plus 7. And that is equal to our output y, our dependent variable, after we put on our independent variable 2. And negative 4 plus 7, using our integers rules, adding with opposite signs means subtracting. 7 minus 4 is 3. So the 7 is the bigger number. Absolute value-wise, it is positive, so the answer is positive 3. Pretty straightforward on evaluating our function rules, ladies and gentlemen. Plug and chug, it's all you got to do. So now we're going to the key idea on functions as tables and graphs. 2 more ways to represent functions: tables and graphs. So now it's taking us up to 4 ways to represent a function with tables and graphs. So as you can see, we have a function table. This is our table of inputs and outputs. And our input is x, our output is y, and they do create the xy ordered pairs that can then be plotted on a graph. Another way of representing our functions, put those ordered pairs on a graph, and then by drawing a line through those points, you'll notice that all those points fall on the line, we can create a graph that shows all the solutions of the function. So notice, here's our second way of learning the function rule, y equals x plus 2. And when we put in a 1, we get out a 3, a 2, we get out a 4, a 3, we put out a 5, we graph those. And now we can recognize that when we represent it on a graph, that I can go to another point on the graph, say right here. That ordered pair is 4, 6. If I put in a 4 for x, 4 plus 2 is in fact 6. So when we represent using a graph, we actually draw a line which will represent all the solutions to that function when we evaluate that function. Okay, that we just did a moment ago, evaluating the function. Excuse me. So our third way to represent is using tables. Our fourth way to represent is using graphs. That first way I will remind you before this video is over. So we're going to do that right now. We're going to actually do both of them at the same time. In graphing this function, it says graph the function y equals negative x plus 3 using the inputs negative 1, 0, 1, and 2. Make an input-output table. Another name, another way of representing a graph. So actually, that's the 5th way. We actually learned 2 ways. Anyway, oh, no, I messed up. That is our first way. That was the first way we represent it. Ordered pairs are another way. Anyhow, so we're going to make a function table using an input-output table. And we're just going to go like this. We're going to draw our line, our x and our y. When our inputs, they told us our inputs are negative 1, 0, 1, and 2. So we're going to make our ordered pairs using that. If you want a separate column to actually write your ordered pairs, you certainly can. However, when you write it this way, you just know that you have ordered pairs. So now when I plug in negative 1 for x, a negative 1 becomes a positive 1, plus 3 is 4. If I put in a 0, negative 0, well, there's no such thing. 0 plus 3 is still 3. If I put in a 1, negative 1 plus 3 is actually 2. And if I put in a 2, negative 2 plus 3 is actually a 1. All right? So we can see it's a function. We can actually describe it because as x increases by 1, y decreases by 1. So now we're going to go and we're going to say, hey, these are our ordered pairs. negative 1, 4, 0, 3, 1, 2, and 2, 1. And we're actually going to graph those points. Negative 1 and 4. We have 0, 3. We have 1, 2. And we have 2, 1. And of course, I'm going to do the best I can to draw a straight line through those since I can't use a straight edge. And there we go, drawing a line through the graph. We can see that we've just now represented the function on a graph after representing it in our function table. And we've graphed it, and that graph, if I had drawn a perfectly straight line through those points, would have shown more solutions. In fact, it would show all the solutions, at least all the ones that fit on the graph. All right? So our third way of representing using a function table, that's an input-output table. You might call it a mapping diagram as we get to our first lesson. And then, of course, our table is the fourth way we learn. Now let's do that using a real-life situation. It says the distance m in miles. Traveled by a car is 35 times the number of gallons of gasoline used by the car. Write and graph a function that describes the relationship between G and M. So now you have to decide which one of those is the dependent and the independent, because the dependent is our input X and the dependent is our output Y. So do the number of gallons of gas used depend on the miles, or do the number of miles driven depend on the gas used? Well, it just so happens that our input-output table, our input would be gallons of gas, our output would be our miles. All right. And we're going to write a function rule, so we're going to actually do our second way of learning to represent a function. So the distance, m, that's miles. It's already told by a car is 30 times the number of gas, so 35 times the number of gallons. If you want to actually interpret that, that means you're traveling 35 miles per gallon. That's how you would interpret that. 35 miles for every gallon of gas used. So, of course, the easiest one, if we didn't use any gallons of gas, we wouldn't be traveling anywhere. That's an easy one. Let's talk about if we used 1 gallon of gas. So if I put a 1 in there, 35 times 1, we should travel 35 miles. If I put in a 2, 35 times 2 is 70. And let's just for giggles put in a 5. 35 times 5 is 175. And so now we have some ordered pairs that we can use in our real life situation. Let's go to our graph, and our X is going to be the number of gallons of gas. Our Y is the number of miles driven. And I'm just going to go by I'm going to skip. So every 2 lines represents a gallon, so I can have a half a gallon there. And then I have 2 gallons, and I have 3 gallons, and 4 gallons, and 5 gallons, and up to 6 gallons of gas. The number of miles driven, well, I got to make a scale that goes up to at least 175. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 lines. So I'm going to go by 20 gallons per line. So 20, 40, 60, 80, 100. 1, 2, 3, 4, 5. Yeah, 5 times 20 is 100. 120, 140, 160, 180, 200, 220. All right. So there we have it. And now I'm going to graph those points so that we can see what that line looks like. So we know if we go 0, it's 0. So we can put a point right there at 0, 0. 1 is 35, so 1 go up here, that's 20. And 35 is going to roughly be in there. And then 2 is 70, so 2 go up 60. If that's 80, then 70 is right in the middle. Oh, wait a minute. Huh, I put the 1 in the wrong spot. 1 goes right here. There we go. And then we said 5, 175. So we're going to go all the way up here. There's 180, so 175 is going to be roughly right there. And of course, if I draw my line, it would go through them all. And that would represent the number of miles I traveled. Of course, your scale could be different. You could be using different numbers. You could have made a scale by 5s, a scale by 10 gallons. Who knows, which would represent, it just look a little different, but it would still represent the same data. So ladies and gentlemen, that's how you use a real life situation. One creates a function rule to represent the function. 2, we have a table that represents the function. And 3, we have a graph that represents the function. 3 ways of representing one situation, all of them helping us. Moving right along, ladies and gentlemen, we have our summary of representations of functions. Well, we have the word way. We didn't quite talk about that, even though we used the words to represent functions in our previous video. And then we wrote an equation. And then we had our input-output table we just talked about, our mapping diagram from our first lesson, graphing we just did. So lots of ways to represent functions, all listed at the bottom of your notes to help you summarize and what's going on. Ladies and gentlemen, let's finish off with our quick write. Our last one, going to make it easy on you. Evaluating the function y equals negative 1/2 x plus 3 when x is 4. Go ahead and write that into your quick write. Ladies and gentlemen, thank you so much for your participation, your attitude, and your effort. I so look forward to talking with you about representations of functions tomorrow in class. Please come with questions. Bye now.